uninclined plane question. So we've got our parcel moving down the slope, and for this we want to have a very clear force diagram. So you make sure you draw it out, you label all your forces. So we're going to have the weight, which is 3.5 g. There's going to be some sort of reaction going on. It's a rough plane, so as it's moving down the slope, we're going to have friction acting against the motion. Model's particle, it's got speed at the top, oh, that's already on this diagram, of 12 meters per second. And there is nothing else said about any forces acting on it. So what do we want to do? We want to find the energy loss. So we want to look at energy. So what have we got? So point A, point B. We're going to have gravitational potential energy and kinetic energy. So point B, I'm going to set the gravitational potential energy to be 0. I can then have a look at my triangle to see what my change in height is going to be. So this is 20 degrees. It said there's 14 meters between them, which makes the change in height 14 sine 20. That's the opposite side. So the gravitational potential energy at A, the change, is going to be 3.5 g times the height is 14 sine 20. There's going to be kinetic energy. Now it's moving at both point A and B, so there's kinetic energy at both. So remember that's a half mv squared. I always like to do a little table, make sure I've got all the energy. Right, and the question is energy lost. Oops. So my energy lost is going to be how much I started with, which is the gravitational potential energy at A plus the kinetic energy at A, and then take off what I've got left at B, which is the kinetic energy. So we can just work out all those numbers if you substitute everything in. Okay, and I'm just going to round that to 2 significant figures because I used gravity as 9.8. Okay, right, well that's a little bit of a hint for the next bit. So part B, they want to find the coefficient of friction. But where does friction come into this? Well, friction is involved in the work done because there's work done against friction. So our work done is the force we're doing work against, which in this case is friction, times the distance moved. And our work is the energy that we've lost. So that must have been work. Use your more accurate answer when you're doing workings. So that's going to be friction, and the distance is 14, which makes our friction force 21.731 and some numbers. Right, so now we've got that. We need the coefficient of friction. Now friction must be at its maximum because it's overcome friction and it's moving. Remember, the maximum friction is mu times r, so I need to get the reaction force, and I can do that by resolving perpendicular to the plane. There is no movement in that direction, so that means that my reaction force, that angle there is going to be 20 degrees, so my action force must be 3.5 g cos 20 degrees because I want the adjacent side. So I can put these things together. So my maximum friction must be equal to mu times my reaction, and you can rearrange that and you can find that mu is 0.67 to 2 significant figures, because once again I use the fact that G was 9.8 as you're told to on the front of the paper.